Semiconductor materials are used in all sorts of electronic devices. These can range from transistors in your phone or laptop to solar cells that are used for energy harvesting, as with the one seen here. Now, as you can see, these materials are typically deployed as thin films, which have very intricate architectures. And as these devices get smaller and more efficient, we need to realize new, highly controlled techniques by which we can fabricate them. Aerosol-assisted chemical vapor deposition is an attractive, scalable technique which you can use to do this. You start with a chemical precursor, which you spray onto a substrate where it can decompose into your target thin film. The act of aerosolizing your precursor circumvents the need to volatilize it, which is typical for conventional chemical vapor deposition methods. However, having said this, the design of your precursor can heavily affect the quality of the thin film that you deposit. My name is Ted Robson, and at the University of Bath I'm working on the design and synthesis of new chemical precursors for the fabrication of thin film semiconductors. I've targeted zinc sulfide as it's a promising semiconductor for solar cell applications, but it's also a nice model system to aim for. Having looked through the literature, I designed this series of zinc thioamidate chemicals as precursors, with the R group changing for these four chemical species. Unfortunately, I was unable to synthesize these ones on the right hand side, but I was able to successfully synthesize all four of the chemical species on the left and characterize them using X-ray crystallography. Now I wanted to see whether they would decompose into zinc sulfide by cleaving off this section of the ligand. I did that by doing thermogravimetric analysis. So you take the molecule and heat it up to see if you get a residual mass which is corresponding to zinc sulfide. In 3 cases they looked very promising, but in the 4th case, which is the chemical species of the isopropyl group, it showed an element of volatility, which is not ideal for chemical vapor deposition. So I now have 3 chemicals which appear to decompose into zinc sulfide. So my next steps are to use these to run deposition trials of all 3. If these depositions are successful, I'll be able to synthesize analogous precursors for other metals so that I can deposit things like molybdenum sulfide or tungsten sulfide, which are also interesting semiconductors. Thank you for listening.